Welcome back. We're at our third little mini lecture that combined together make our overall presentation or my overall presentation for climate as it relates to the built industry. Um, so this is our not just our last mini lecture for that, but it's also our last lecture for Building Tech 1. I hope you've enjoyed the lectures and your summer watching these and reviewing them. And it's been a pleasure working with you remotely to do this. So what with it with this final little piece, we want to talk about just some very basic steps that um, architects, interior architects, construction managers, the whole building industry is taking to begin to remediate the the CO2 output as it relates to creating the built environment and making buildings and the built environment more sustainable. And I do want to highlight again that we're just brushing the very surface of this topic. Next semester, we'll get into very deep into, let's say, um, um, alternatives, additives instead of cement to create concrete. We'll look at mass timber to understand that as a new construction material that didn't exist, at least, in any significant way 20 years ago. Um, this is just really to introduce you to the very idea, right, that we are involved as an industry in CO output, that stabilities of climates are important to us in our design, um, and that we have a role in mitigating our contribution to that issue of CO2 emissions and buildup. And as usual, I have got my pen. Good. So, uh, I want to apologize if there's non-architects in the group here. Really, I'm talking about the building industry at this point. So what can the built industry do, right, to make buildings more sustainable? And so there's really two responsibilities that we have taken on, and they're related. As a broad set of industries related, right, to making the built environment. First is simply reduce the energy use and resource use of buildings. Okay. This can be done in very technical ways, special additives to concrete instead of cement, recycled steel, a whole host of different things. But that's mostly on the construction side right there. But it really begins with the design process, that the design of the building or its interiors um, has to be done in a way that thinks about sustainability, that thinks about um, how it will use energy, how it will create comfortable interiors without the use of significant interiors. And then as it develops on your design board, what materials will you use to build it, what structural systems you'll use, and what mechanical and active systems will be needed to create that comfortable environment that we want on the inside of buildings, right? And as I mentioned in the last talk, the very fact that the building industry contributes so significantly to CO2 carbon is also a remarkable opportunity for us to help the situation by reducing the amount of CO2 we produce as a series of industries, right? And so we're uniquely positioned, right, to help shape the future in this regard, right? So, and we do that, right, by influencing how buildings are designed, what materials are used, and then how we operate buildings, right, over their life. And I could add to that now how we reuse buildings, how we make sure that they just don't end up in a landfill at their end of their useful life. If they can be reused, can we design it in a way to make sure it's reused, for instance, or that it can be disassembled in a way where we can reuse the various pieces to it? Can we use materials that will endure, right, so that we can reuse them later, right? And if you just simply look at conventional buildings and what we call green buildings, that's sustainable buildings, green buildings. Um, net zero buildings. There's a whole slew of terms for it. So green buildings. You can begin to see that we can really begin to reduce simply by using particular design and construction strategies, nothing deeply innovative, to reduce aspects of energy use, um, carbon emissions, water use, solid waste, all the things that can become problematic about the built environment and the use of buildings, that if we take steps, right, that we could find that a conventional building would consume 42% of the world's total energy. So we've kind of run through that, right? We can save up to 50% of that. And this is on a global scale we're talking about here, right? We can reduce that by half, right? If we were to implement sustainable strategies throughout the building industry and throughout the built environment industries. And that works its way down there. I won't go through each one of them, right? So over here, right? So energy use, heating, cooling, lighting, appliances, equipment, all those types of things, right? We want to be conscious of that. Our reliance on fossil fuels, right? Are there other alternative energy uses that are renewable? Um, and I think we've already kind of made that point a little bit earlier. Now this is just talking about building operations right now, right? Not the construction of it, but just the operations of it, right? So, we're looking to cut that number down is what it really comes down to it, right? So one of the main, I'm going to just kind of go through several large category strategies that we're using as industries. This is particularly on the design side to address some of the issues that we have. And so the first, right, is passive design strategies to design your building in a way that utilizes natural conditions of air movement, sunlight, opportunities that plantings and trees in particular give you for shade, to utilize those to reduce the building's reliance on mechanical means, because the mechanical means requires energy. Okay. And the more that we can use a way to create a comfortable interior without using energy from off-site, let's say, then we're reducing overall carbon input. So oriented the building to maximize light if you're in a condition, right, as we talked about before, being in a climatic zone where that's a beneficial thing. The opposite would be the case if you're, let's say, down in New Mexico. You would want to orient your building to reduce that. You would have small openings, right? Thick walls and things like that. Use natural ventilation that moves air through it. We've talked about that, how cool air comes into the building, it gets warmer. And if there's an opportunity, like a shaft or an atrium or centralized space for the air to move up in that space and escape out, that creates movement through movement of the air through the building and cools it to some degree. It's unusual for passive systems and strategies to take care of all the needs of creating a habitable, comfortable interior, but they can significantly reduce the need for outside energy. And when I say outside energy, the fact is too, it would be different from this, right? There is active systems that you can have internal to it. So in this instance, right, you can see some solar panels right there. That's pulling energy right from here, right from the sun, and it's all operating within the building like that. But here you see some other passive ones, right, where you have a large deciduous tree that's kind of blocking the sun, right? It will let sun in the wintertime when it is colder and you want that solar gain. You see the air coming in, and as it warms, it will move up and escape out in that direction, starting to have a green roof right there. that's going to create some extra insulation. It's going to create a kind of a microclimate right there that makes cool things down. There's other things noted in here that aren't necessarily passive. Um, energy efficient hot water heater and cooling system and stuff like that. Um, the use of natural materials is another passive system, passive strategy as well. And so those are some of the basic ones. But the key is passive design strategies. You will learn a lot about passive design strategies in like Building Tech 3 and 4 and onward. The next is where we have to use active systems, use very energy efficient systems, right? So we install mechanical systems, lighting, HVAC, all those types of things that don't consume as much energy as the older technologies that we had for those types of systems. And also to use renewable sources. Wind and sun are the primary types of renewable energy. Water can be renewable if it's, recycled and reused and things like that. But unlike wind and sun, water is not an infinite um, uh, resource for us. There's only so much water on the planet, and there's only so much fresh water, unsalted water on the planet. And so that, is something you have to work internally and reuse water in that way. So we're looking to simply make buildings more energy efficient. They just don't consume as much energy to do the same amount of work that they were doing before, right? So LED lights are one of those main things. High performance insulation. You often see exterior walls are getting thicker in a lot of areas because we need more insulation to meet the requirements of energy efficiency that are set by energy codes and things like that. Smart HVAC systems. HVAC is basically air conditioning systems, heating and cooling systems. And so smart systems run more efficiently instead of just keeping the temperature constantly throughout the day. It'll moderate it throughout the time. It can sense where people are within a room, within a structure, and focus its energy in those areas and not in unoccupied areas and things like that. And then, of course, as we've said, right, renewable energy sources is the thing too. Moving down as this kind of regenerates. Other strategy is to use sustainable materials, right? So we've got passive systems. When we have to use active systems, we're using efficient ones. And when we're selecting materials, this is materials from foundations, right, all the way to doorknobs, right? We want to look at sustainable materials. And by sustainable, we can mean a lot of different things. There's a lot of different ways for things to become sustainable, right? You can look at materials that are abundant and easily replaced and grown. So bamboo as a wood is very easily sourced and ethically sourced. Using recycled material, like in steel. In the United States, we use a lot of recycled steel. Low carbon concrete, that's replacing cement with other additives that create the concrete without loss of strength, durability. But the other thing we'll just look at is the locally sourced materials, right? So to keep in mind that the whole supply chain of materials contributes to CO2 emissions related to the built environment. So if I have to deliver steel from Japan or China to the United States, right? That transportation is a burden on the environment that we need to consider. So if we can have it internally through that recycled process, I don't, despite everyone's hopes, I don't think the steel industry is coming back in the United States, right? But it would be beneficial if it did, because then we would not be paying a significant amount of money for that transportation, right? And so locally sourced material is important. So one key piece then, right, is to think about right here, the entire supply chain that brings the material to the construction site, not just the material itself, right? And its overall use in the building, but what it costs to even get there, right? And so this is kind of a list of things that make what they'd call eco-friendly material and techniques. Of course, it has to be green because that's, I don't know, what we picked to kind of mark and brand this effort, right? But materials that are easily renewable, right? So like trees, for instance, if we are harvesting from a tree farm that is sustainable practices, that's really great. If we're taking wood, and don't get me wrong, it's beautiful wood from the Amazon, that's not a renewable resource. That's just not going to grow back in the next 100 years. It's going to take centuries, right, for that to grow back. It's not really renewable, right? Reuse water as much as possible. Use materials that eventually are biodegradable if the building gets demolished, or if it needs to be reused and refitted. Again, recycle and reuse other things. Embodied energy, that's a little bit more technical. We don't have to worry about that, but here's a locally available. That means you're not transporting it and paying all the cost of that in terms of environmental impact. Durability, things that last, right? Energy efficient equipment and things like that. And then we try to do it in a way that reduces air, land, and water pollution. Okay? So next, right, so we've got passive solar, energy efficiency. Okay, stick with me. Sustainable materials, there's sustainable sourcing also as related to that, and also to follow any number of guidelines that have been established for best practices in developing sustainable buildings. And there's a whole slew of them. Energy Star is for appliances to know that you're buying something efficient. Green building, the very architecture building you're studying in, half of it is certified as a LEED green building. And there's a whole slew of them. And each one of those provides guidance on how to meet certain standards, whether you go for their certification or not, to make sure your building is being designed and constructed in a way that remediates the building's impact on the environment. And then there's some kind of design things that the industries are taking. First is to design for adaptability, essentially that the building can be changed and altered over time. So it's built either in a very flexible design or a modular design. So the building can have multiple uses over time. And so we know they don't last forever, but they don't have to go to waste when they reach the end of life. So can we take them apart and reuse them? Or can we simply take a piece away and add a new piece? So that type of adaptability can help the building have a longer lifespan. Or if we don't need it, we can disassemble it and use it elsewhere. Other are what's called nature-based solutions is another term for this, called biophilic design. That's just kind of a big term. I don't expect you to know it. You'll get to know it in a later class, but it's using kind of nature within the building instead of just around the building to help it. It's part of the building, right? So green roofs, green walls, making large open spaces with trees, bushes, water within the building as a way of creating microclimates that help create comfortable interior environments. by creating shade, by um, creating areas with some humidity, and um, uh, to take in carbon as a tree does and put out oxygen. So all those things, right, really start to come into play when using those types of solutions. And then the last is to engage in what we call the circular economy in architecture. And this has to do with recycling and the reuse of buildings. Now, of course, we can design buildings that are flexible, but we have a lot of old buildings. So there's two things we can do that are much more preferable than simply tearing it down and putting it into the landfill. And that is to either find a way of reusing the building, renovating it, altering it for a new use, or dismantling it and reusing its parts. I don't know if any of you were around while Scranton Lace building was being renovated. And as they did that, they really kind of carefully took that building apart. And they had piles of steel. They had a block full of bricks. All of that carefully stacked and organized because they were selling it. They're selling it to be used elsewhere, right? And so it's not just circular in terms of a building economy, but it's actually a monetary part of the monetary economy. So you can come to a building like this, and there's still value there. Value either in its reuse because already, right, you have you have an enclosure, you have a structure, um, and so that saves a lot of carbon already. The demolition of it would produce carbon. So by not demolishing, you're saving that. And then investing in it, right, for its continues has also cultural and community, positive cultural and community aspects, saving of an old historic building, for instance, that has meaning to a community. So there's tremendous benefits, right, to either trying to save the building, or if you can't, to disassemble it in a way, right, that permits the reuses of its pieces. And that's what we have for just a basic introduction to the building industry and climate, um, why climate's important to us, how it affects design, what the issues are in terms of climate change, creating an unstable condition that's unpredictable for design, our contribution to that problem, and then lastly, the basic steps that we can take to begin to remediate this issue. Thanks again, and enjoy the rest of your summer.